systems and payload innovation. Modern satellite missions are being transformed by a new generation of technology, from advanced imaging payloads and AI-enabled sensing to onboard processing, miniaturized electronics and reconfigurable architectures. This session will explore how these innovations are enhancing satellite performance, operational flexibility, and mission capabilities across both commercial and strategic applications. To chair and moderate this important discussion, it is my privilege to invite on stage Mr. Alexander Jeuck, ICT and Space Tech professional, whose expertise spans international space markets and technology advisory at the highest level. We also welcome our distinguished speakers and panelists on the stage, Lieutenant Colonel V. Ramanathan, retired VP Strategic Liaison KaleidEO, Mr.Nitish Singh, founder and CEO Astrogate, Mr.Punit Badeka, founder Aeon Space Labs, Mr.Sumod K, founder and CEO Graviton Space, Mr. Kannan K, co-founder and CEO AugSense Lab. Thank you all for joining us today. It's an absolute honor to have you with us. Now I kindly hand over the stage to the chair and moderator of the session as well as the panelists. Thank you.
Thank you. Thank you for announcing the speakers and the panelists. So unfortunately we are missing still Punit. So I hope he's joining us within the next minutes. But I think to use most of the time, we will start. I have today here 5 companies on the panel which are doing remarkable businesses and projects. What I find very interesting is that with these 5 companies here on the panel, we can see very well the way how projects can be developed. But I think also we will hear within the discussion how difficult it may be to decide if you focus on systems, subsystems, or if you have to take hand on the complete system, because only if you control the entire system, you may reach your target. And it's not only about the payload, it's about the integration of the payload, it's the application, yeah. At the end of the day, I treat myself as, I call myself an engineer of applied science, and I think we all having the idea that making mission possible. At the end of the day, the products need to serve a mission and they need to fulfill a purpose. And as a first step, I would ask the panelists to give a short information about the vision, mission of their company, and at the same time give us an idea on the verticals they are active today and where they are integrating their solutions. Beside that, I would like also to hear why people working with them or should work with them, what makes them very special, what is driving the company, and then we will go step by step. Only 3-4 sentences, and then I come up with the next question. We keep it most interactive. What I also would like to do is maybe I stop after 3 rounds here, and then we will make some questions to the audience, and at the end, once more, some questions to the audience. Thank you. So we will start from the right side, and then we flip, okay?
Thank you, Chair. And first of all, thank you SIA for including me in this panel. I'm also really happy the payload discussions are coming to the morning panels. It used to be in the last day, last panel. Okay, so let me introduce myself. I'm Kannan, co-founder and CEO of AugSense Lab, standing for Augmented Sensing Lab. We are a deep tech startup from Trivandrum, working on the intersection of quantum photonics and RF signal processing, catering into aerospace, defense, and climate sensing. So what we are building a quantum photonics based RF receiver, which is able to detect any signal from DC to terahertz, which would be the smallest swap and with a higher sensitive than any conventional receivers. And we are trying to use this for solutions like electronic warfare, radiometry constellation for climate sensing, ground penetrating radar for subsurface imaging. So the challenge we are trying to solve is currently antenna developers have a huge challenge in designing RF antennas because it has to be designed for a particular frequency. And also the problem is, if it is a low frequency, the antenna size is very big. For a higher frequency, it is small. Also what happens is you talk to any radar developers, you have L-band, S-band, every mission you need antennas and receivers need to be designed separately. We are trying to solve that challenge by creating a unique atomic receiver which can be programmable to SAR or LN system or radiometry sensors, which can be for any missions for aerospace, drone or satellite or a ground-based missions.
Thank you. And then we go to the next round, and I go now to the left. And also here, I would like to make a small correction for everyone. So it's Mr. Sumod. Kurramaup is the correct one. Kurramaup. Okay.
Thanks for that. Hi. First of all, thank you for having me here. Good morning, everyone. I'm Sumod Kurramaup, founder and CEO of Graviton Space. We are a very early stage startup based out of Bangalore. By the time I started my journey with Graviton, I realized that the space aspirations of people have gone very high. We are talking about number of satellites to be done. UAE talks about, landing on, asteroids, mining asteroids and whatnot. But typically, if we look at, what I found was there is a huge deficit of an ecosystem which can be a reliable, modular and scalable ecosystem which can support the huge rising demands of satellite. And with that thought, I wanted to position the company as a systems company, tier 1, to support small satellite market to make critical systems like onboard computers, attitude determination and control systems, and payload handling systems for small satellites. And what we are trying to build is to do a software-defined paradigm, reimagining the complete satellite mission, not to be a slave system, wherein it is command-driven, but an intelligent system which can facilitate mission orchestration and smart missions to reduce the exposure of ground-based operations. Like if you look at the number of operators has not gone high as the number of satellites has gone. So that's some gap that I'm trying to build. I think we will catch up further on the electronics and what we are trying to do.
Exactly.
Thank you.
Okay. So next one is please Mr. Colonel Ramanathan.
Good morning, everyone. And at the outset, my sincere thanks to SIA-INDIA for giving myself and the company an opportunity to take part in this panel today. I have a long background in imagery intelligence in the Indian Defence Forces, and currently I am part of a group of companies. SatSure is the mother company, and it's 100% owned subsidiary KaleidEO. We are basically into Earth observation intelligence. That is to say, we are full stack into Earth observation, starting from the payloads. We are developing 2 electro-optical payloads. Both are integrated into 2 programs with the Government of India. And post the payload, we are also doing in the downstream sector, which is our the bigger chunk of the cake. That is the analytics on the data which comes down. We are also data and sensor agnostic. That is to say, it's not just let's say optical data, but we are equally good with SAR and hyperspectral, as well as with the platforms. It can be space-based, drone-based platforms. And we are also, recently you would have heard just last week, we have received funding through the Technology Adoption Fund. That is basically for us to develop a platform called Dharini, which will be our geospatial foundation model, helping the Indian side of things with every possible geospatial application you could think of, starting from agriculture, forestry, mining, land use, land cover, and even to certain defense applications. Thanks a lot. Looking forward for this panel. Thank you.
Thank you. Yes, before we hand over, I think what's interesting here is that with KaleidEO, you're having in principle, you were creating that out of a group, yeah? So that means to vertically integrate certain services, certain hardware, certain assets, and it will be interesting in the later discussion also to see what is the positioning of the companies, yeah, and what is possible, what money needs to be taken in the hands, and how to develop it further. Now we come to Nitish from Astrogate. Please tell us about your undertaking.
Thank you, Alexander. Yeah, lovely to be part of this panel where we see mostly the entire range of payload and systems are being covered. Talking about Astrogate and me, I'm the founder and CEO at Astrogate Labs. We primarily develop laser communication solutions. Our mission is basically to make communication easier for satellites. It needs to be faster, it needs to be more secure, it needs to be, go down at least 10 times the cost. Why laser communications? Well, this is the only scalable solution that we see can do long range secure communication. You think about radio frequency in low Earth orbit right now, think about scaling that to geostationary infrastructure and even LEO beyond. You need ground stations of over 30-meter antenna sizes. That simply is not scalable. The CapEx and OpEx itself is way too large for any particular solution integrator to at least get returns on that. So coming on to the specific solutions that we are giving out is twofolds on the space side. So one is direct to earth communications or satellite to ground communications as we say. And then there's the inter-satellite communication. We have already developed the satellite to ground communication. In fact, this is the compact in the whole industry. Very low size, volume and swap. Around 5 kilograms that can do over 10 Gbps of communication back to ground. What we are also doing is we are basically collaborating across the globe. We did cross-compatibility testing with different ground station operators, and soon a majority of the commercial ground station operators also we would be doing. So that enables us to provide an end-to-end solution, which is basically you don't need to worry about the ground stations, you don't need to worry about the satellite terminal. Both are in fact well tested, and right from day one, once your LEOP operations are finished, you can basically just get multi-gigabit downlink with partner ground stations. That's what we aim to do.
Thank you, Nitish. So here, interesting, at least so for me, yeah, this is a company who is taking care not only of the asset into space, it also tries to build systems for the ground stations. And I believe what is important, and we maybe go later in the discussion again here, there's also, of course, applications like free space optics, where you can already generate revenue before your big dream is maybe happening in some years, yeah? I think it's always interesting also to not only hear what the companies are doing, it's also where they are coming from. When did they start? How did they raise money? And maybe you can give us a little bit an idea how you achieved what you have achieved right now, and what is then the next milestones you have in mind. Yeah. So we start here.
Thanks a lot. So in our case, Satcom as a company was founded around 8 years ago, and somewhere in 2017-18, and we had a humble start back in Bangalore. Company today is headquartered in Bangalore, and we have people working out of all of the country. The subsidiary KaleidEO was basically born because the amount of data which we consumed as far as our the primary solution was concerned was an agriculture-focused solution, in which we have combined banking, the insurance company with a humble Indian farmer. So this required a lot of data, the geospatial data coming out of satellites. And what we realized, if you end up buying the ones which are high resolution and good ones, naturally the cost goes up, and the ones which are freely available, they have their own limitations. So that is where KaleidEO as a company started in 2021, and we've got together a team of people. In the entirety between the two companies, we have around 160 to 170 odd employees today. We are through with our Series A funding, and currently our Series B round is also in progress, about to finish rather. And like I've already mentioned, we've had a technology adoption fund coming to us just last week from the Government of India. And yeah, so we have people spread out all over the country, but generally speaking, the tech side and the the solution side, they sit out of Bangalore. And we have a fantastic team which has been put together from people, Indians, basically going outside the country as well to gain their own expertise and knowledge, and then coming back and contributing to us. We also have a lot of youngsters who come to us for interning, and we have a very, very good intern holding rate. That is to say, our absorption rate for the intern who joins us is very high. He generally converts, or he or she generally converts back to us as a regular employee. As I see it today, we are now, like I said, already into 2 programs with the Government of India, and on the software side also, we are now about to develop the platform called Dharini. We look at scaling up our payload systems. We are also partnering with 3 more companies for a program called PPP, Public-Private Partnership, which entails other sensors as well. So we are looking at scaling up on that end, providing solutions and helping out friendly foreign nations, African nations, our Southeast Asian partners, South Americans, and the globe as such in the whole, with these geospatial solutions, which maybe those countries may not be able to afford at their scale, but certainly we as a partner and India as a overall friendly elder brother can certainly offer it to those countries. Thank you.
Thank you. So, Kannan, please. Thank you.
So, AugSense Lab is started in 2019 by 5 founders. The history is we were working in 25 to 30 years in medical imaging. So mostly with the Siemens, Philips, etc. So the one of the dream was we try to take that knowledge of computer tomography to other industry. That's how AugSense Lab started, and in that journey we went into weather to build a GNSS tomography based hyperlocal weather sensing system. But to realize that, we had to find out a receiver which is high sensitive to find out a phase shift, even a smaller phase shift or a smaller deviation. That journey led us to quantum, and that's how the current positioning of, we are building an atomic receiver and atomic receiver based modalities for aerospace and defense.
Thank you. Okay. We go to the left once more, yeah, and take to Sumod about your
thanks.
journey.
So I'm a very green startup, as I said. We started off in September 2024. I have a very different thought as I build the technology and value within Graviton. I have not raised money so far, and I have been always looking from a customer's perspective, because what I strongly believe is building a product for space upstream market itself is a challenge, but the bigger challenge stands is adaptation of that product to your customers. And I wanted to break that barrier at the start itself. So I spent considerable amount of time talking to the customers, identifying the gaps. And within that journey, I got a couple of customers excited, thanks to the time that I have been in the industry and my connects within Indian, European, and Australian market. I had a couple of contracts relevant to the IP that I am building in. And that actually helped me bootstrap the company for my 18 months of journey. We are a team of around 13 to 14 people and 2 balance sheets wherein very little bit profit has been marked. So I consider that as a huge achievement, wherein there is a cash from operation in my first year of business. Now, currently, I need to fast track my product development. So I have been in talks with a couple of VCs, looking at a very small check on pre-seed to start with. And then next year would be my actual fundraise that I have planned to do a 3 million. Currently a 14-member team, completely based out of Bangalore, with an expansion plan to UAE sooner. And then once the products are ready, then to US is how I intended to structure Graviton out. And I intend not to be a very big team, a 20, 21 member team, creating value, continuously innovating, and scaling is what I have thought of. So that's my plan with the Graviton.
Thank you, and all the best for all the funding rounds you try to achieve, and highly respected to see how you building up with bootstrap, with own initiatives, with, in principle, with what is possible, small steps, step by step. But also here we see at the end of the day to leverage and scale things, yeah, money is needed. And before we talk more about where's the money coming from and where to get it, to Nitish, please tell us a little bit more about the heritage and the background of the company and how many employees you're having today, for example.
Sure. So Astrogate Lab started in early 2018. We have been developing core systems for the laser communications technology. And one of the core systems that we have built is primarily the pointing acquisition and tracking systems. Okay, you will see laser communication. There are some heritage suppliers that can give you static links. So let's say a rooftop communications close to around 5 kilometer link ranges that can be done. But that's not where our company stands. Our core IP is how we can make laser communications for mobile platforms. Think about on the ground level ships. Think about aircrafts, stratospheric balloons, or you go up to space, then obviously you have satellites, and then satellites also you can have in multiple orbits, low Earth orbit, geostationary, even beyond lunar. So that's the core capability that we invested time in bringing this, develop that indigenously here in India. Then we also looked at use cases where it can be served, and very interestingly, we got use cases within the Navy. So we have been doing secure communications for ship-to-ship based laser communication. We started with the POC, and now we are looking at deployment orders also coming soon. From that, it was also able to expand use cases within the defense ecosystem. Defense primarily it is because of the security. It cannot be jammed. It cannot be snooped. That's where the global onset of what we are seeing right now demands the communication links to be. On the space side of things, we have our terminal that's already at TRL-7. We are collaborating across the globe. We also are working in the UK with a few organizations developing systems for intersatellite links. Our intersatellite terminal, we are looking to get it out by mid of 27. That would be a flight version that would be ready, and we are looking to integrate it with partners and do the first in India intersatellite laser communications soon.
Excellent. I think intersatellite links in general is a very interesting topic, and at the same time we have seen our SpaceX, for example, even promoting their own developed laser links to other companies. Yeah. And then we're having, in principle, the possibilities and the potential with Internet of Space, yeah, how it's called these days, with all the issues with sea cables, yeah, especially during, let's say, political difficult times, yeah, where a tanker and an anchor is good enough to disconnect businesses and more. Let's talk about we're talking already about the applications and verticals, but which one are the most interesting ones and which are building now revenue streams today? And where do you see then the revenue streams tomorrow and maybe in future? It could be the same, but maybe today you're focusing first on something else, and then the long-term plan may be different. So maybe Kannan?
So we are still an early stage. I would say from a technology point of view, we are edging towards TRL4 and 5 in both in the application level and in the core platform level. So we, for a conventional receiver point of view, we have started our piloting with the Kerala Disaster Management Authority for a system to predict cloud burst and hence predicting the landslide for Western Ghat. Even the atomic receiver is still in the ground-based lab level. So initially, next 2 to 3 years, the company's journey is more focusing on ground-based use cases, be it ELIT, be it ground stations, we are thinking from a space, a realistic estimation will be 4 years from now, or maybe a little bit optimistic estimation. So, but that doesn't mean that we have currently, we have orders coming from a ground station point of view and from the LN system point of view. Yeah, so that would be our focus in the next 2 to 3 years.
Thank you. And it's a very interesting topic. Quantum sensors, if you did not look into it, maybe you take some time, because you can do things with quantum sensors you cannot do with other things. Yeah? And for example, for Navy, it's interesting to trace submarines. It's interesting to see how magnetic fields are behaving. Yeah? Even for utility companies, power companies, it could be very helpful to have such sensors in space or even on the ground. The challenge here is sometimes if you talk about payloads, of course it's the power requirements they have, the form factor they are having, but maybe that's another step. Yeah, maybe we are talking also about KaleidEO, because you are at the, I say, most advanced position right now, where you're already having, in principle, a product, and you can now leverage it and scale it on group level, of course, also. But where do you yourself going over the next 2 to 3 years?
Yeah, thanks a lot. So I'll take this in two halves, since we are basically two companies. And first, on the SatSure side, basically our products and solutions, which are basically what a human or an individual will see day in, day out. What KaleidEO is developing is way up, that is seeing us, not we can't see that. So on the SatSure side, we started off, like I said, our primary, the biggest focus as a solution was integrating the Indian humble farmer with the bank for a loan, as well as the insurance company for an insurance to his crop and his agricultural solutions. So initially the catch was that if a farmer had to have a loan, he would have to go naturally approach a bank or else get caught in the loan sharks which are there. But if he has to go to a bank, the process of getting a loan would be anywhere between 45 to 60 days, which also included a physical visit of his, to his farm, then checking all documents, including government land records and everything. We have simplified the solution from 60 days to hardly 30 minutes now. So all the farmer has to do is go to a rural bank, which is looking after his district, and from there he just submits a few documents regarding the ownership proof of his land, and rest everything we are basically pulling out of satellite data, things like his farming practices over the last 2 to 3 years, which now results in what we call as a agri score. So this, based on this agri score, which would be kind of very similar to the CIBIL score which all of us have, a bank is now confident on giving him a loan. He is given the loan, and the loan is also naturally these days being digitized, lands up in his bank as soon as possible. And the insurance company is also now quite satisfied that yes, in the last 3 years his farming practices have been at par, right, and he has delivered, so he is also given an insurance. Currently, this system is online in not all states in India, but only a few states where the land records are also digitized. So I would say kind of a bottleneck is where the land record has to be digitized and available in an API format for us to pull. As I see scaling up in this, we would like to now scale it up to pan-India level naturally. We are approaching all, at least following up with all state governments as soon as their land records get digitized. They can also be integrated onto this portal, and this facility can be extended to every state. Other than this, we have more solutions in the power transmission utility sector. We have a solution in the aviation sector. The aviation sector is quite interesting. It is basically combining, it is basically onboarding India and the Indian airport. So this has got to do with the ground segment or the airport segment, not the flying and the aircraft segment. Basically getting them at par with the International Civil Aviation Organization, ICAO's guidelines for how an international airport has to be managed. The way a kind of a digital twin of the airport itself is developed and is available for anybody to access across the globe. We have done it for 5 Airport Authority of India managed airports in India. We are all aware that in India there are 2 kinds of airports. One is an AAI managed airport, and the other one is a private airport in a few metro cities. So we have already done for 5 AAI airports. They are live on the net. You can browse them right now through your mobile devices as well. And we are trying to now scale this up to at least all AAI airports within India, and then later take it on to certain private airports as well, trying to cover our Indian side of things. And after this is deployed, then certainly some, let's say, Southeast Asian countries, if they also need the solution for their, for getting onboarded onto the ICAO guidelines. Third, we have a solution towards the forestry where we are already, there's a project which has been financed by Jeuck, Japan International Cooperation Agency. And this is a project which is going on with the Rajasthan State Forest Department, where basically we have created a digital twin for the entire state of Rajasthan, plotting out the kind of forest cover which is available in the state, differentiating in between the tree types, which is, let's say, an eucalyptus or a mango tree. And so these tree types are differentiated. And it gives them a dashboard in which they can daily put in their own feeds on any changes which they have observed. And then it also gives them a possibility of a weekly and a monthly follow-up in forms of reports.
Excellent. So I think there's a lot of chances now also after implementing these solutions in India for export. That's what we are seeing here. You are already on the path to go beyond India. Now,
just give me 30 seconds for the hardware as well. Don't mind.
Okay.
So on the hardware side, like I said, we have 2 payloads which are coming up with us. They have all reached satisfactory TRL rates, TRL stages as per their requirements. They both are optical payloads, and as we see it today, an optical payload is the primary, I would say, the data generator. I am not in any way trying to turn down the SAR and the hyperspectral ones. They are equally required in their particular fields. They are certainly better in some things. But as we know it, primarily it is optical which comes up. So we have 2 of them. One is a wide swath payload, which is basically the game changer, which generally other companies do not develop. So this payload gives you a resolution of 1 meter on ground, but the game changer is the 60 kilometers of swath. So image covering 60 kilometers in one go. You can image district levels in one go. So this will give a certain, a benefit in capturing so much of data in one go, as well as reduce the revisit periods. Thank you for that.
Thank you. Okay, before I go to the left, once more Nitish, because it comes to my mind. If you are doing optics, now free space optics is something you can implement right now, but are you also already starting to deliver some laser ground terminals, for example, to ground station as a service companies who are building up infrastructure, or you are engaged also in QKD project discussions? We did not talk so far about that.
Yeah, so I'll just give chronologically how we have scaled our laser communication solutions. So specifically on the user one front, we started on side of the defense side of things, so primarily Navy. Those have already gotten into scaled orders and all. We have been doing revenues for the last 2 years consistently. Now we are seeing deployment versions coming for across all the tri-forces. So there are army use cases that you can do for mobile links. You can also do for air forces. On the air force side, we are primarily doing it through collaboration with DRDO. And on the Navy side, we are directly doing with the users, Navy and Army side of things. Coming to the space side of things, so on the Space to Ground solutions, our terminal, we already have few orders coming it up for the next year. So this will be for our smallest microsat terminal, that is 10 kg class. These are primarily within the European market as we see. On the use cases front, because Alexander, you just mentioned, SpaceX, Starlink, and obviously the IPO that just happened. So there are definitely use cases. Laser communication has been used with private companies. However, I would say it's a closed market. SpaceX, they do things themselves. Starlink has been using laser communications developed by themselves for quite some years now. They are the ones who has actually done that at much larger scale. But however, there are use cases that has come from the space development agencies in US. So there's a lot. Globally, I would say there are 5 companies only who are able to provide laser communication links at scale. Mynaric is one of your bigger companies out there. That's currently under Rocket Labs. So on the space side of things, the inter-satellite communication, we have few partnerships coming within India as well as in the UK and EU system, primarily for use cases within data relay constellations. There are also Now we are talking about in-orbit compute, your space data centers. So we have a few use cases where we are going to supply the laser communication terminals for those also in the next 18 months or so. So that's where we are seeing scale on the space side of things. It's primarily inter-satellite link, but also the space to ground, not as a terminal sales, but primarily as a data services itself. There's obviously a ground station as a service market already flourishing. On the RF ecosystem, we see that heavily changing it to the space to ground side as well, primarily because of payloads such as Earth observation, high imaging payload. You have hyperspectral SAR images that generates data of over 100 gigabytes or so. So within a single contact period of 5-minute duration, we could offload over 300 gigabytes of downlink. That enables the satellite to do more things. It doesn't, the energy that you're spending in communicating with the ground station, that energy can be better utilized in operating more of the payload. Coming to the last question that you mentioned on the quantum side of things also. So yeah, there's a few projects that in early stages of discussions, both pre-space laser communication, you talk about the ground station, the satellite terminal and everything, and the quantum aspects of it, specifically quantum key distribution, that can only be done through free space at scale. There are fiber-based deployment, but those also have limits in terms of the distance. You can do 100 kilometers, 200 kilometers. But we are talking about distributing keys over a longer range that can only be done through free space. And now free space and optic, what has common is the shared infrastructure. You can have the same pointing precision and tracking systems. You can have the same ground stations, plug in your quantum transmitter or receiver, and you're good to go. So that's where we are heading towards, where we are having some conversations where we can fit the quantum side of transmitter receivers with our core technology in PAT and on the laser communication system side.
Thank you, quite interesting. So now what I found also interesting already, what you mentioned from Graviton Space, you are a young company, but you are also aggregating the ideas and the possibilities on a global scale, I want to say. Yeah? So you are working actively also with Australia, for example. Yeah? Maybe you can also explain a little bit more how this is helping you in the phase you are now in this international cooperation, and how you can leverage that in India. Yeah? Of course, with Australia, there's some good relation. Yeah.
So my presence in the market early, so I've been in SpaceTech from 2019. Graviton is a new initiative. So through that, I was connected pretty well into European and Australian markets. So coming to how it started off with Graviton, what I realized is there are companies who give electronics hardware alone, and flight software for complex missions becomes kind of a gap wherein people spend a lot of time and money to develop it. So that was an early traction that I could build into Graviton. So I had few paying customers for whom we made the flight software. This was not so the product that I'm building is called as Graviton Cognitive Core, towards which I'm working, which is, you can say, the Rolls Royce, which has all facilities, AI and mission orchestration, payload prioritization and whatnot. But currently, as walking towards the journey, the basic bus management flight software is something which was ready, which I could get early traction, and I started selling onto that. Onto the TRL levels, onto the hardware side, currently we are at TRL 6, and then few of other engagements onto custom building avionics, again for satellite systems, is something that came in, which kind of gave good credibility to the team that we can design, build and deliver space systems. And the customer coming back, the Australian customer, that was a payload interface system that we had made for them. And that payload interface was a FPGA-based board. We did it quite fast. Mr. Pawan Goenka mentioned about reliability and agility going together. We could do the custom build of that hardware in 8 months of time. And we did the assembly integration test here in India and shipped it to Australia, and the customer has come back for the repeat order. So I think that gives a huge endorsement to the ecosystem, talent, as well as the ability of India, startup like Graviton, to build for global space and kind of capture the value. On a future note, where the revenue will come, that is the second part of your question, from Graviton, we would be positioned as a hardware sale, an interface, and a software as a subscription model. wherein IC software would be the highest revenue generating thing that would come in, but it's always clubbed to the core, the hardware core that I'm going to build. So that's what I'm working towards, and that's where I was telling that my next fundraise is focused towards that. So I see that happening in another 18 months' time to walk forward with. So yeah, keeping fingers crossed. Things are moving fine.
Okay, thank you. So we also had the buzzword AI, so we make a tick because that's on all the panels now, but it is there. But this also reminds me, I said we will give you the chance to ask questions. Are there any questions? Please feel free to ask the panelists. Otherwise, we go ahead and maybe later when someone from the organizers is giving us a time note, so we will then go back for one more round of questions. So what I wanted to ask is, from your perspective, what are the biggest challenges that need to be addressed for the satellite payload builders to scale in India? And how should satellite integrators, which we have not really on the table, and payload players like you position themselves only complementary, or is it also more and more a need that you build your own buses? Because that's what I've seen in Europe, for example. There had been many companies starting with building sensors, but at the end of the day, for whatever good reason, they were starting to build the satellite bus as well. Sometimes it's for grants, for founding reasons, but otherwise it's also they didn't want to give out the responsibility to integrate sensitive payloads. Now, for example, your quantum sensor payload, you want to make sure that it's integrated in a very secure environment at the end of the day. Yeah, maybe you can share your expertise in that and how you think about it, building your own bus around your payload, or you will definitely look out for partners. And if you're looking out for partners, do you find these partners in India already, or you are also looking for overseas partner hosting your payload or integrating the payload? We start with Kannan, please.
Currently, from a satellite bus point of view, we have not, because our discussions are relatively at the early stage, we have not seen a gap. Means obviously we have satellite bus manufacturers are coming up in India. They have their growth path is relatively good, but a visible gap is in the VLEO segment for certain data product which we wanted to do. We have not seen a player who has immediate plans towards that. But on the other side, the worrying is on the payload itself, because satellite industry is not just one tech. We have the industry which I represent, maybe for Nitish also, we are heavily reliant on the photonics in this. But as a country, we are in the initial stage of it.
Okay, thank you. I want to give everyone a last chance to say one sentence where you are standing with integrating payloads. Are you going with partners? Are you building your own buses?
So in terms of the payload integration and everything that we do in-house only, but coming to obviously providing as a integration on the satellite bus, we are working with European partners for this as a hosted payload missions and even subsequent commercial missions that are coming in. What are the challenges that I see specifically from an optical communication payload integration? It's different than packaging or integrating any other payload. Even at the satellite integration, even when it moves to the launch vehicle side, you have a few operations to do, and not everyone has that capability to do it. So someone who is already being into optical systems or use cases of that, let's say Earth observation constellations and all companies that are doing that, they would have the know-how to integrate such systems, specifically testing aspects of those things. So for those reasons, we are already working with European partners for that. This is for obviously the first demonstration mission. future commercial missions, obviously it will be the satellite integrator side only that the integration will be there with Astrogate participating on those integration activities.
Thank you. Short question here again. Yeah. How do you plan to work the payload? I think at your stage, maybe you are looking more for partners than building all on your own. Yeah.
So, being in touch with most of the guys who are doing satellites and even payloads today, because I am working closely with them as a systems person, I have a very different perspective. What I see is that there is tremendous potential that has come up within the Indian sector within the time. Even from the buses side, if you look at, there have been few missions that have been launched. I see that we are not very far. Another 2 to 3 years, you will find the whole ecosystem available in and around. And specifically where I see a huge gap is companies like Graviton to support the satellite bus manufacturers, wherein they can be the integrators, focus on their IPs, focus on their payloads, and then look at systems that can support to deliver the maximum value of the mission that they are looking at. Coming up with a system is something, but how much of the use case and what kind of outcome can your system provide onto the precision, onto the compute, onto autonomy, and all of those is something that I see a way forward where India has to come up. But yeah, I've been in this industry for the past 6-7 years now. 2019 when I started, all of these, I don't think these questions were not even relevant. But with the pace that the private industry has come in, I think in 3 years' time you will see the whole ecosystem being there. Yeah.
Right. So before I'm closing the session, also giving you a chance for one sentence, yeah? And,
Thanks a lot.
to balance then.
So I have let's say, a rounded opinion between all of us. That is to say that SatShore started as a data analytics company, and in 2021, like what he mentioned, that we did feel a need to have our own integral data, which we can work upon, and hence KaleidEO started. But then we realized that one company cannot be doing every possible thing related to the space industry. This is where I think partnerships really matter. We need to explore the industry and try and find out who could be the best partner in providing us a bus, in the launch service, in the ground station services, in which SatShore and KaleidEO is not there. And even those, let's say, crucial subsystems of the payload. Here also, one more thing which is quite important is need for a standardization amongst the industry as far as these subsystems are concerned and the way they get integrated onto the bus itself. That is also something which, like Sumod said, I think we are reaching there at quite a good pace, and we are open to both Indian partners as in, obviously we're in the same geographical region, it will be easier for us to communicate and integrate. But otherwise, like a satellite is a global asset, and hence we are also open to any global partnership for that. Thanks a lot.
Thank you very much. And unfortunately, no questions anymore from the audience, but I give you the chance. Have we time for one question? To keep the session interactive, I always like to have one question at least.
Hi. Am I audible? Yes, fantastic. Yeah, very good morning. Myself, Shashank Kumar from KaleidEO Space System. My question goes to Nitish. So, Nitish, you mentioned about onboard computing. Can you elaborate a bit on that front? Because that with the free space or FSO, how is Astrogate is looking into this, or is this something that is on the tables, or is it in the plan? Thank you.
Yeah, my mention of onboard computing primarily deals from orbital data centers and all what's coming in. Obviously, some part of compute you can do directly on your satellite itself. Some things could be offloaded to another ones. Now, we ourselves don't do onboard computing. Where we are coming in is basically, if you have a orbital compute unit separately and you want to communicate with that unit, let's say your satellite needs to communicate to that particular satellite, the only way it can communicate at those high speed rates is through laser communications. That's where we come in. We can provide the laser communication systems, the whole solution around it.
Excellent. I think, thank you for the question. Yeah, we missed that so far to talk about space data centers, but I think there would be, we could talk an hour more, yeah, and we would find very interesting things, yeah. But thank you very much. Please join me in an applause for the panelists, and I'm looking forward, potentially we can follow up our discussion next year again and see where you are with all your initiatives. Thank you, gentlemen. Thank you.
A very warm thank you to our distinguished chair and our esteemed panelists. That was a forward-looking conversation on the next generation of satellite technologies. I now request all the panelists and the esteemed chair to kindly come forward for a group photograph. Thank you everyone. It was an honor to have you with us today.